Hello. In this video, we're going to look at graphing exponential functions, and in particular, we're going to look at some exponential functions with a fair amount of transformations. So if you look here, we have the following function, y equals -3 times 2 to the power of x plus 1. So our base graph is going to be 2 to the power of x. But if you notice, there's a -3 in front and a plus 1 on the outside. Now, what do each one of these numbers represent? Well, the -3 right here is going to represent a vertical stretch, and the plus 1 is going to represent a vertical translation. So both of these are going to affect the y values. The y values are going to be multiplied by -3, and then we're going to add 1 to them. Now, if you can memorize the base graph, that's definitely a good idea, but if you don't have it memorized, you can just go ahead and recreate it. We have x and then 2 to the power of x. So we go ahead and say x equals -1, 0, and 1. Then we plug in our values. So when you plug in -1, you get 2 to the power of -1, which is 1/2. When you plug in 0, you get 2 to the 0, which is 1. When you plug in 1, you get 2 to the 1, which is 2. So our basic graph, again, if we write it a little nicer here, looks like this. -1, 0, and 1, 1/2, 1, and 2. Now we take these and we have to transform them into a new table of values, where the x values stay the same, -1, 0, and 1, but the y values get multiplied by -3, and then add 1. Let's start with the easy numbers. So 2 times -3 is -6, plus 1 is -5. 1 times -3 is -3, plus 1 is -2. 1/2 times -3 is going to be -3/2, plus 1, which is going to be -1/2. All right. Now we take these points and we go ahead and plot them on our graph. So we have the point -1 and 1/2, 0 and -2. Oops, sorry, let's try that again. We have the point -1 and -1/2 right there. 0, -2, and 1 and -5. Now, we could go ahead and just sort of connect the dots and make some exponential shape, but we need one last feature. We need to know where the horizontal asymptote is, because that's going to help guide our graph. And if you remember, we had a plus 1 at the very end. That plus 1 means we're going to have a horizontal asymptote at y equals 1. Now with that guideline, we can go ahead and connect the dots, and we have this beautiful graph ready to go. All right, let's try another one. Graph the function y equals -1/2 times 2 to the x plus 1 plus 3. So again, we've got a vertical stretch, we've got a horizontal translation, and another vertical translation. So let's set up our basic table. X and 2 to the x, -1, 0, and 1, 1/2, 1, and 2. And then we will get the following new table. So again, let's do the x values here because those are easy. We just go ahead and subtract 1. So we get -2, -1, and 0. For the y values, we have to multiply by -1/2 and then add 3. So let's start with the 2. 2 times -1/2 is going to be -1, plus 3 will be +2. Then -1 times -1/2, 1 times -1/2, that will be, well, -1/2. So 1 times -1/2 plus 3, -1/2 plus 3, so 5/2. And -1/2 times 1/2 plus 3. Ooh, that one's a little messy. It's going to be -1/4 plus 3. So 3 times 4 is 12. So that's going to give us 11/4. Now remember, this plus 3 means we're going to have a horizontal asymptote at y equals 3. And if we want, we could actually throw that on first on our graph. It doesn't really matter the order that you do these, whether you get the asymptote or the points. As long as you have all of your features, you should be good to go. So let's go ahead and put that on our graph. we'll have the following. Our horizontal asymptote at 3 our point at negative, or let's go 0 and 2. So here we've got our point at 0, 2, negative 1 and 5 over 2, and negative 2 and 11 over 4. So again, we go ahead and connect the dots. And there's our exponential. Now for this graph, it might have been nice to grab one more point just to the right of the y-axis, but I think this is all right. All right, here's another one. I'd encourage you to give this one a try before I go ahead and graph it. See what you come up with for your points, and then we'll go ahead and put them on the graph. All right, hopefully you've given this a try. We have x, and in this case, we have 1/2 to the power of x as our base function. So for that, we have to go ahead and do negative 1, 0, and 1. 1/2 to the negative 1 will be 2. 1/2 to the 0 is 1, and then this will be 1/2. However, this is definitely a bit of a nasty question because this hasn't been written in its proper form. To read the transformations, we have to write it as negative x minus 2. So we're going to be taking the x values, making them negative, and then adding 2 to them. The y values are a little more straightforward. We multiply by 4, and then we subtract 2. So let's go ahead and get those new values on our table. For x, well, let's do the y values first. Those are a little easier. So we'll go ahead and multiply by 4 and then subtract 2. So 2 times 4 is 8, minus 2 is 6. 1 times 4 is 4, minus 2 is 2. 1/2 times 4 is 2, minus 2 is 0. And just remember, this is going to be our horizontal asymptote at y equals negative 2. Okay, how about those x values? Well, like I said, we have to make them negative, and then we have to add 2. So if we take negative 1 and make it negative, well, it's going to become positive. And then we add 2 to it, so we have 1 plus 2 is 3. 0 plus 2 is 2. And here we'll have negative 1 plus 2 is 1. All right, so we go ahead and take those points. We grab our asymptote at negative 2, and we sketch a graph. So there's our asymptote, horizontal asymptote at y equals negative 2. We've got our points at 3 and 6. 1, 2, 3, 4, 5, 6. 2 and 2. 1 and 0. Now again, for this graph, it might be nice to get another point just so we're closer to the asymptote, but we can also just eyeball it. As long as we come down and approach the asymptote, we should be good to go. Sorry, that arrow is a little bit messy there. Let's fix that up. Perfect. Now we have a few more concepts to look at. What we finished doing on those last 3 examples is covered in worksheet 6 and 6.5, but I want us to take a look at the other way. What if we're given the graph and we need to figure out the equation? So here, for example, we have y equals b to the x. We know it's just a basic exponential because they've told us the equation, but they haven't told us what the equation is. Is it 2 to the x, 3 to the x, 4 to the x? Who knows? What we have to do is figure it out. And it's definitely important to go ahead and find some points on the graph. So there's a point here at 0, 1. But that doesn't really tell us anything because every exponential goes through 0, 1 if it hasn't been transformed. But we have a point over here at 1 and 4. And I think that's going to help us figure out the base. If we plug that point into the equation, we get 4 equals b to the power of 1, which means 4 equals b. Therefore, b is 4. And so our equation is y equals 4 to the power of x. This point right here was able to help us determine the type of exponential. Now, obviously, we have to make it a little more difficult. So here we have an exponential where we know that it's just a basic base, but it has been transformed with a minus c. That means it's been translated horizontally. And we can see that because it doesn't have a point at 0, 1. Now, let's go ahead and say, okay, well, we've got a point here at 2 and 1. We've got a point here at 3 and 2. We've even got a point over here at 4 and 4. What type of exponential do we have? What's going on here? Well, one thing we can do is we could plug in some of these numbers. So if we plug in the first one to the equation, we get 4 equals b to the 4 minus c. But if you notice, that equation has two variables. It has a b and a c. So let's plug in another equation. Let's do 2 equals b to the 3 minus c. Oh, darn, again, we have two variables. It's a little tricky when you have an equation with two variables. You can't solve it right away. But what you can do is you can take these two equations and you can divide the equations. You might not have seen this before. It's a nifty little trick. Normally we add or subtract equations, but you can actually divide equations. Let's go ahead and see what we get. If we take 4 divided by 2, that's going to give us 2. If we take b to the 4 minus c divided by b to the 3 minus c, well, let's write that out. B to the 4 minus c, b to the 3 minus c. Because we're dividing and they have the same base, we're allowed to subtract the exponents. So using exponent rules, this gives us b to the 4 minus c, and then we subtract 3 minus c. So we get 2 equals b to the 4 minus c minus 3 plus c. And the c's cancel. 2 equals, well, 4 minus 3 is going to be 1, and we get b equals to 2. Now, I know that was a little weird, but it's a kind of interesting technique. If you have 2 points or 3 points or however many points you have, you can go ahead and plug them in just like normal and then divide the equations to figure out the missing b value. Now that we know the missing b value, we can take this and plug it into any equation we want. And we'll go ahead and get 4 equals 2 to the 4 minus c. And we can solve this like a regular exponential. So 2 to the 2 equals 2 to the 4 minus c. We drop the base and we get 2 equals 4 minus c. So c equals 4 minus 2. So c is equal to 2. So therefore our equation is y equals 2 to the x minus 2. And you can kind of see this here because, well, if we start at the beginning, if we kind of imagine this as the beginning point, it used to be on the y-axis and it's been moved over 2. And we can also see the graph is kind of going up based on doubling. Each time we go over the y values, doubling and doubling. So it's a base 2 exponential. All right, so I'll give you guys a real tough one. Go ahead and try this one on your own. You've got y equals b to the x minus c plus d. We have 3 points, 2, 2, 3, 3, 4, 5. Go ahead and plug in the points and try to solve for the exponential equation. All right, so assuming you've given this a try, you should have something like this. When you plug in the point 2, 2, you get 2 equals b to the 2 minus c plus d. Then if you plug in 3, you get 3 equals b to the 3 minus c plus d. Or you get 5 equals b to the 4 minus c plus d. Now, what we should do is we should solve for d first. And I mean, we do have 3 equations here, so you could do sort of 3 equations, 3 unknowns, but it's a little bit easier to actually look right here. If we look at the graph, we can see that there is a horizontal asymptote at y equal to 1. And so that means d has to be equal to 1 just based on that feature. If we use that, we can actually go back here and we can fix up our equation. Instead of having plus d, we'll just have plus 1. Now, we don't actually need to use all of the equations here. We could just use these last 2. And we'll go ahead and divide them but I think it would be easier before we divide them to isolate for the exponential. We don't want to have that plus 1 there. We want to move the plus 1 over to the other side. So that's going to give us the following. 2 equals b to the 3 minus c, and 4 equals b to the 4 minus c. Now if we divide them, 4 divided by 2 is going to be 2, equals b to the 4 minus c over b to the 3 minus c. That means we have 2 equals b to the 4 minus c minus 3 plus c. So 2 equals b to the 1, or b equals 2. So just like the other question, we definitely have b equal to 2. And if you take that and plug it into any of the equations, you should find c equal to 2 as well. So our final equation will be y equals 2 to the x minus 2 plus 1. All right, here's one that's got all sorts of fun things going on. We have a giant graph. We have a b to the x minus c plus d. And again, we need to determine those 3 values. So go ahead and pause the video, give it a try, and then we'll check your answer. All right, so similar to the last one, we should definitely look at that horizontal asymptote. The horizontal asymptote is at y equals negative 4, and so that means d is equal to negative 4. Now let's go ahead and plug in some points. So we have negative 3 equals b to the negative 2 minus c minus 4. And we have negative 1 equals b to the negative 3 minus c minus 4. So we'll go ahead and rearrange those equations by getting the d to the other side. That'll give us 1 equals b to the negative 2 minus c, and 3 equals b to the negative 3 minus c. That's add 4 to both sides. Right, taking that negative 4 and moving it on over. So now we can divide the equations. So we'll get 1 divided by 3 is 1/3. B to the negative 2 minus c over b to the negative 3 minus c. So 1/3 equals b to the negative 2 minus c plus 3 plus c. Those c's cancel. And you get 1/3 equals to b. So now we have our b value, we have our d value. Finally, you can go ahead and solve for c. I'll just do that up over here. So we get 1 equals b to the negative 2. Oh, now we know the b. So 1 equals 1/3 to the negative 2 minus c. Now again, this is a bit of a weird equation. Maybe this one isn't the easiest to use, but we know that 1 is equal to 1/3 to the 0. And so we can treat this just like our exponential equations that we're used to solving. So we get the same base with a little cheat there, 1/3 to the 0. We drop the base, we get 0 equals negative 2 minus c. So c equals negative 2. And so our final equation then is y equals 1/3 x to the minus 2, which means we'd write minus negative 2 or plus 2, and then minus 4. All right, one last problem here. You can take notes on this one. I'm going to tell you that y equals b to the x minus c plus d. I'll give you 2 points and the asymptote. Your job is to determine the equation. All right, so hopefully you gave that a try. Instead of giving you the graph, I'm just giving you the points, but it should be the same approach. This tells you that d equals negative 4, equals negative 1. Here, your 0.24 and 10 can be plugged in, so we get 4 equals b to the 2 minus c minus 1, and 0 equals b to the 1 minus c minus 1. We go ahead and move the negative 1 over, so we get 5 equals b to the 2 minus c, and 1 equals b to the 1 minus c. Then we divide, and we get 5 equals b to the 2 minus c over b to the 1 minus c. So 5 equals b to the 2 minus c minus 1 plus c. And so b equals 5. Finally, we take that and solve for c. So 4 equals 5 to the 2 minus c minus 1. 5 equals 5 to the 2 minus c, so we'll call that 5 to the 1. Drop the base, and you get c equals 1. So our final equation is y equals 5 to the x minus 1 minus 1. And if you wanted, you could check this on Desmos. It would indeed go through these points and have the following asymptote. So for practice, you can try Unit 8, Worksheet 7, and 7.5. Hopefully you enjoyed graphing these exponentials. And as always, thanks for watching.